Okay, we're gonna change this up. I'm gonna leave the amount of resistance on there. I'm gonna change these because we're gonna add something in here that's gonna make it a little bit different, okay? Whenever you're running whenever you're running wires to light bulbs that are someplace remote, right? So it's a little ways away from this. The resistance of the wires is going to play into it a little bit. Let's say that this first light bulb is far enough away that it's like having, let's say, 5 ohms of resistance in this wire. I add 5 ohms of resistance in there. That's going to make a difference on everything else, right? And what if in between these, I'm also going to have, like, in between these are going to be kind of close together. I'm going to have 1 ohm of resistance. And in between these, I'll have another ohm of resistance. And in between these, I'll have another ohm of resistance, okay? Well, if I have resistance on the wires going to these, I'm also going to have resistance in the wire coming back from these, right? These are all wired up in parallel, but I'm going to have to add another resistance for here. It's 5 ohms. Because I'll have 5 ohms of resistance in the hot wire and the neutral wire, right? 1 ohm resistance in between the two of these and the wire coming back. 1 ohm of resistance in between the two of these, and that's an ugly resistor. And the wire coming back, and another one in this. Okay, so we had those totals that we had all worked out. This is going to change everything up. Right now, do I still have 120 volts here? I don't, do I? Because I'm going to have some voltage drop across this. We don't even know how much voltage drop we're going to have, right? We don't even know how much voltage drop we're going to have. This might be a little bit complex to be starting out with because we're going to have to do a lot of math to figure out what it is, right? There's a lot of different current paths. The current's going to go through this one light, or some of the current's going to go through this other light. Some of it's going to go through all of this resistance and through that light, and some of it's going to come clear over here through that light. Boom, okay? So how do we find all of that? We're going to have to use math to find all these parallel resistances. But this is definitely going to require a little bit of redrawing, isn't it? Probably should start out with a little bit skinnier. We're going to redraw this. Actually, you know what? I'm going to cut this last. I'm going to take the last 2 of these off. Okay. This is still going to be a complex circuit. Oops. This was 90, was it? Let's figure out what our total resistance is going to be. To find this out, though, we're not going to use these 2 in parallel because this one in parallel isn't just 90, is it? I'm going to redraw it. Oops, that's ugly. There, nice. I'm going to redraw it like this, okay? Can I do that? So I'm taking this values and I'm going to move it over to this. When I redraw this, I'm going to combine this one and this one and this one all together to make this combined total of those 3 resistances. And then all the rest of these are going to be the same. So this is going to be 5 ohms, 5 ohms, still 100 ohms. This one no longer is 90 ohms. What's that one?
92.
Is it 92? It's 92 because all you have to do is add these up, right? 90 plus 1 and 1 and 92. So this would be 92 ohms. Okay. Now I can take this one and do them in parallel. I can find out what that total resistance is, and I'll redraw it. This is still going to be 5 ohms. This will be 5 ohms. And I'm gonna take both of these and I'm gonna combine them together to make this one single resistance. Okay? So what would this resistance be on this one? Scooch over a little, AJ. Could I use the product over the sum formula for that?
Yes.
I could. 100 times 92 over 100 plus 92, so that's what? 9200 over 192? That's what?
47.9.
47.9? That's going to be the total ohms of this resistance. And I'm not going to call this a resistor anymore because this is a combined resistance of these resistances. And this resistance is a combination of these three resistors right here, right? Now I can take this, I could redraw it again with only one resistor in there, or I can just add these together because that's all I need to have to get the total, right? It's what? 55.9 ohms total. And this is still going to have 120 volts, right?
Yeah.
This will tell me exactly what I have on the amps, won't it? How many amps is that? 120 divided by 55.9? 2.195?
No, 2.15.
Wouldn't it be 57.9?
Yeah.
It would be 57.9.
I'm sorry, I did it wrong. It is 57.9. 47.9 plus 10, right? So is that still this?
Oh, I thought that was a 3 on top.
Oh no, it's the same as the.
Oh, my bad.
This is my good artwork here.
I thought it was a 3, that's why I added 8.
Oops. Now it's some dumb freaking number. Okay, 5 ohms. So 57.9. So what does that change this to be? What's 120 divided by 57.9? 2.07 amps total. This 2.07 amps total is going to be the same here and the same here. Right? Those are all going to be the same. This total ohms of resistance is going to be the same on both too. 57.9. All right. So coming back to this, we have our total amps. We can take this total amps and we can set it on all of these, right? So, scooch over a little. I'm going to put this 2.07 on this, 2.07 on this, and 2.07 amps on this. Okay? Then I can figure out what my voltage drops are going to be in all of these places. What's 2.07 times 5?
10.35.
10.35. So I'm going to have 10.35 volts dropped across there. 10.35 volts dropped across there. And what is 2.07 times 47.9? It's what?
37.
I doubt it's 37. If this is 10 and this is 10 and I'm subtracting that from 120, I'm going to have a lot more than 37. 47.9 times 2 times. 47.9 times 2.07.
Oh, 99.
99 point what? So this 99.15 is going to be the same on these. So this is going to be different than 99.15 because we have to figure out the amps flowing through here to find out what the voltage drop is going to be on each of these, right? So if we have 99.15 divided by 92, how many amps are going to flow through that? 99.15 divided by 92.
You got 1.077.
1.077. 1.077 is going to be the same here because all three of these are in series. Okay, and then we can take 1.077 times 90 and it'll tell us the voltage drop across each one of these. 1.07 times 1, that one's easy. Take 2 volts away from this, 97. It's going to be 97 volts through here, right? Is that right? Somebody with a calculator? Bueller? 90 times 1.077?
96.93.
All right. Boom. Okay. Then we're going to do the same thing with this. We're going to know the amps going through this. All of these amps, 2.07, are going to go through this. 2.07 are going to go through this. Then we can determine the voltage drop. 2.07 times 5, 10.14. We already did that over there, didn't we? Oh, 10.35, my bad. All right, got it all done.